All right, doing number two. Number two, 24 centimeter tall object, 55 centimeters in front of a thin lens with a focal length of minus 15. Minus 15 says that we are going to be working with a minus lens. Like I said, we're going to try and make this happen. This is fun sheet 2 for thin lens. Fun sheet 2, number 2. So we've got 24 centimeter object, 55 centimeter object distance. It's going to be a minus 15 focal length. So what that means, so we're going to throw it over here. I'm trying to make this a little bit, I don't know, I haven't figured out which way I like it best. So here's our center line. Here's our lens. We know that it's a minus lens. So we're going to draw our picture here. We know that our focal point is going to be on the left side because the left side is negative, right side is positive. So one focal length, it's going to be minus 15 centimeters because it's on the left. I'm going to leave it there for you guys. Object is located, here's the second focal length, 2 times this, which is minus 30, which means that, oh, it's even further. So here's the third. This is F, 2F, 3F. This is going to be minus 45. And so this object is all the way out here. It's like here-ish. It's before that fourth focal length. There's our object. It's 24 centimeters tall. All right. And so it is 55 centimeters out. We are going to be looking for, again, V, M, and I. Currently, from the information that we have, because it was a negative focal length, we know that this is a minus lens. This is a minus lens because of that negative focal length. We know each of the F's here because each of these count. It's just more of the focal length. It's double the focal length, triple the focal length. The fourth, quadruple the focal length is going to be 60, so on and so forth. And we know that the object's 24 centimeters tall. We're looking for image distance next. Image distance is going to be that minus 1 over u. In this case, is going to be minus 55 centimeters plus 1 over v equals 1 over the focal length, which is that minus 15. Because these are two negatives, it makes it a positive, and you subtract that from both sides, which gives us 1 over v equals negative 1/15 minus 1/55. Going to get our handy dandy calculator. Who did I pick that up from? There's a YouTuber I watch or something that I have picked that up from. So negative 1 divided by 15 minus 1/55. Is that correct? That is correct. We're getting a negative 0.085 because there's an 8 on the... No, I want to do 4. 0.0848. That's what I'm going to do. So 1 over v is about negative 0.0848. 0848 minus, that's because of accuracy. If you throw that 1 on, you can do a cross multiplication. So 1 equals minus 0.0848 v. So it doesn't really matter which side you write this on, as long as if it is the same, because if you flip it, anyway, not to confuse. Divide both sides by this. So we're going to have 1 over minus 848 equals v. So 1 divided by second. Answer going to be about negative 11.78. I'm pretty sure he's doing to whole numbers. I'm keeping 2 after, so I'm going to put up negative 11.79. So V is about minus 11.79 centimeters. That's what I'm throwing on. I think that it looks better. It's more accurate than the singles. I don't think that we need to have the diopter steps in consideration at the moment. So I'll move that out so you guys aren't all kinds of weirded out by my moving hands. So magnification is next. Magnification equals V minus 11.79 over U, which we know is minus 55, equals the image size, which we don't know, over the object, which is 24. And again, we'll be finding the image size here soon. So if we do negative 11.79 divided by negative 55, we get 0.2144. So we get about 0.2144. So that's going to be magnification, which is equal to the image over the object, 24 centimeters. Throw on, you can cross multiply, where I is about equal to 0.2144 times 24. It's going to be 5.15. So I is about equal to 5.15 centimeters. What does that tell us? This tells us that the image is upright. It's got an erect image. Since it is on the left side up here, it is going to be virtual as well. So it's virtual. So I guess we can fill in our information up here. 0.2144, and then image is about 5.15 centimeters. And then to finish our picture up top, where's the red? There's the red. I'm the most disorganized person that you can have. So here we are. This is what we're looking at right now. Up here on the top. I know that my object is going to be located somewhere between here, between the lens and the focal point, because the object distance, the image distance is minus 11.79. That minus says is here on the left side. 11.79 is somewhere here. I know that the image is going to be upright, and it's going to be shorter than the original object. Yes, so this is... So I guess when we're writing it, you don't technically have to put the minus. Putting the minus says that you know which side of the lens it is on. It also means that you know that that image is virtual because it is on the left side of the lens. When the light hits... I don't know why I didn't just do like a full line. Beep. And then it diverges. It'll go back through. This is way too tall. I always do that. So it should be really tiny. Beep, 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 beep. Beep, 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 beep. Down. And then I keep forgetting that I'm not having you guys follow me very well through the optical center. So that's going to be the optical center. And then my object is going to be, not object, my image is going to be here somewhere. It's going to be where these two meet, right where the glare is. How dare I? So where these two images meet, and it's going to be between F and the lens. Erect virtual image minus lens. Information we need.